So in this video, we have sine times secant times tangent, which is 3 products. And when you look at the trig hexagon, the product of sine times secant, those hinge together to equal tangent. And tangent times tangent is a tangent squared in the numerator. Then that's divided by the cotangent of the quantity pi over 2 minus x, and that's equal to 1. Whenever we see pi over 2 minus x, that's a reminder that we're going to need a cofunction identity, and cofunction identities go across the trig hexagon. So the cofunction of cotangent is tangent, and that'll give us a tangent squared x divided by tangent of x is equal to 1. And from there we can cross multiply. So tangent squared x is equal to tangent of x, and then we're going to go ahead and subtract the tangent of x to get it on the same side as the tangent squared of x, so we can factor out that GCF. So pulling out a tangent of x to the front leaves us a factor of tangent of x minus 1, and then we'll use the zero product property to separate this into two equations. Either tangent of x is equal to 0 or tangent of x minus 1 is equal to 0. So if we use the inverse, then x is the arctangent of 0. And if we'll add 1 to each side in our second equation, and then apply the inverse, x is the arctangent of positive 1. So arctangent of 0 is asking us to find all the angles on the unit circle over the interval 0 to 2 pi that have a tangent value of 0. And our tangents in quadrant 1, if you recall, we have a tangent of 0, 1, undefined up there at pi over 2. Then root 3 is pi over 3. Root 3 over 3 is the tangent of pi over 6. So the angle that has a tangent of 0 would be 0, 2 pi, and then reflecting over the y-axis, pi. So x equals 0, pi, and 2 pi would be our 3 possible answers for tangent of x equals 0. Then for arctangent of 1, that's at pi over 4 in quadrant 1. But tangent is also positive in quadrant 3, and that would be 5 pi over 4. And those would be our two solutions for tangent of x minus 1 is equal to 0. So in the calculator, we're going to check these equations here. See if I can fit this in here. We're going to start by looking at the mode and making sure that we're in radian mode, which we are. And then we're going to put pi over 4 in as our x. And then we have the sine in the numerator. So let's make a fraction here with sine of x times, and then secant is 1 over cosine. So we'll have another fraction, 1 over the cosine of x, and then that's times the tangent of x in the numerator. Denominator is the cotangent, which is 1 over the tangent of the quantity pi over 2 minus x, and that is equal to 1. So when we press enter, we get a 1 back, so we know that pi over 4 checks. Now we're going to look at 5 pi over 4. So we'll store that as x, then we'll arrow up to that equation and copy it down so we don't have to type it again. Press enter, we get a 1, so 5 pi over 4 also checks. Now let's look at our solutions for tangent of x equals 0. So we'll store pi, and then check that one. And we get a domain error, right? Because pi is outside of the domain. And then when we check 0, right, same domain error, and 2 pi is coterminal with 0. So this equation has two solutions, pi over 4 and 5 pi over 4.